All right, folks, it's Bass Action back in action here. On this page of notes, as I mentioned in the last video, we are jumping into our financial formulas. This is going to be our most basic approach to our financial formulas and is intended really just to also get you an understanding of the purpose of our financial formula. So what most of us understand is this idea of simple interest, okay? And simple interest, this I, can be calculated by multiplying a principal amount times a rate times an amount of time. So if we could jot that down if we want, we could say an amount of money and a rate and a time. Now, it is always important that the rate and the time match. So for example, if the rate is an annual rate, then the time needs to be in also an annual amount or an amount of years. So simple interest allows us to just calculate interest for a single period of time, and it just gives us an interest amount. So let's look at that example, and then we'll contrast it with compound interest at the bottom. So let's say that we have a credit union that pays 8% per year, which, by the way, that would be a crazy amount of interest, but we'll play along. So 8% per year, and it's going to say that it's compounded quarterly. And we're going to have $1,000 to invest. Now, if we can use simple interest to calculate the balance at the end of each quarter. Now, this would be a very cumbersome task if we didn't ultimately end up with a compound interest formula, but it's important to understand this general process. So if we wanted to calculate just that interest amount using our simple interest formula, what we would do is we would say, okay, we want to know our interest, and we know that we're investing $1,000, and we know that our rate, and we always have to write that as a decimal, is 8%. So converting that, by the way, we're going to move that decimal point, so it's going to be 0.08. I will tell you that is probably one of the number one mistakes that students make on these problems is they don't convert their decimals and their rates. So we're going to say 0.08. And then when we go to enter our time, we don't want to enter 4 as in 4 times a year. So if it's compounded quarterly and we're compounding and we were calculating it after a single quarter, what we're really doing is we're looking at 1/4 of a year. So now, if we type that into our calculator, what we're going to get is that the interest amount for that period is $20. So at the end of that quarter, the amount in the account, the new balance, is $1,020. So then at the end of the next quarter, what is technically happening is that new balance is being used to calculate interest the next time around. So the next time we calculate interest, we're going to say not $1,000 is in the account. We're going to say we have $1,020 because we're going to get interest on the previous interest. We're still going to have our rate, our same rate of 0.08, and we're still only looking at 1/4 of the year. So when we calculate that, what we get is that our new interest rate, or our new interest earned, I should say, is $20.40. So our final balance after 2 quarters is going to be $1,040.40. Now, you can imagine that if we had to do this for every count, for every single quarter, this would get really tedious. And of course, if we extended the idea to, we're going to calculate interest, monthly or quarter or daily, we would have to do this computation every single solitary time for every single count if we were in a bank, for example. So that would obviously be way too much work to do. So what we can use instead are these compound interest formulas. So the real value of a compound interest formula, okay, so these compound interest formulas, the real value of this is that it's going to allow us to calculate our balance after multiple interest periods. Okay, so after multiple interest periods with only one computation. So, for example, up above, if we wanted to know the balance after a year, instead of having to calculate the interest 4 separate times after each individual quarter, we could just do one computation for the whole year for that compounding quarterly. So our two formulas that we're going to look at are actually closely related to the uninhibited growth computation that we were doing earlier. So the A is going to be our ending, or what is often referred to as our future value. The P is going to be our beginning, or what is sometimes referred to as the present value. Our n's, and you'll notice that there's n 2 places in this formula. This is the number of times interest is calculated. So if it's compounded 300 daily, we're going to put a 365 in there. Our T is the amount of time, so how long we have to wait. So are we going to wait 2 years or 3 years, or are we going to wait 4 days? Like we would have, and if we did 4 days, we'd have to do 4 out of 365. So this is our time. And the R, just as we would expect, the R is our rate. That, of course, has to be converted to a decimal. So we're going to use this formula on the left for the vast majority of our computations, but this formula here on the right that is very not creatively referred to as PERT, because you can tell that that's just the word it spells, is PERT. Okay, the PERT formula is used anytime interest is going to be compounded continuously. So on the previous page, when I said that if it was compounded continuously, we wanted to think E, it's because we're going to be using this formula. A is still our ending amount, or that future value. P is still the beginning amount, or the present value. R is still going to be our rate, and T is still going to be our time. Okay, so let's just jump into some of these. We're going to get them set up, then I'll pause the video for you to try it in your calculator, and then we'll compare our answers. So let's look at how these each compare. So we have $1,000 again, okay? We're going to invest it for 3 years, and we're going to have a 10% rate. Again, these are pretty high rates, but if you're investing not in a savings account, it's maybe not so unusual. Okay, so I want to know the value after these periods of time. So we're looking for a future value. So on our first one here, we're looking for A. Sorry about that. We're looking for A. And I'm investing $1,000. And just plugging into my formula, so I'm going to have 1 plus my rate is 10%. Remember, we have to convert this to a decimal, so we're going to say 0.1. That's my rate. It's compounded annually, so my n is only going to be 1, and then my exponent is going to be 1 times however many years, or in this case 3. For my daily computation, I'm still looking for a future value. I'm still investing $1,000. We're going to have our 1 plus our rate is still the same. This time, we're going to compound it 365 times, so I'm going to put a 365 here. And in my exponent, I'm going to put that 365 again, and I'm still looking at it after 3 years. For our continuously, we have to use the PERT formula. So now we're going to switch our formula just a little bit. So we're going to say we still want the future value. Our principal is still $1,000. The E is just E, that can't change. Our rate is still the same, so now the rate actually goes into the exponent, 0.1, and our time is still 3 years. So each of these can just be typed into our calculator. I will tell you that when I enter these in, just to give you a little hint before I pause it, I typically enter this amount and then let that value, because sometimes it's going to be a weird decimal, carry forward, and I raise it to my exponent, and then I multiply by the 1,000. So on the next one, I would type this in, I would raise it to my power, then multiply by 1,000. I would take e to the power and multiply by 1,000. So try that in your calculator, pause the video, and we'll compare our answers. Okay, so for starters, if these are not the answers that you got, most likely you're having some type of a calculator issue. So let's talk in class. So just make sure to remind me when we go through this in class that you're not sure how to get these values in your calculator. It's a good just one-on-one conversation for us. The other thing that I do want to call your attention to is how I rounded these. I didn't give any rounding directions because these were talking about money. So it makes the most sense to take these to 2 decimal places as if we were taking these out to the cents, the pennies. The next thing that I want you to kind of just draw your attention to is that our answers are similar, but we did get a big jump, I think, pretty significant jump between compounding annually versus daily. So once a year, we're not getting a lot of interest on our interest, but daily, we're getting a lot more repetition of interest on the interest that we've earned. So we get that big leap. But notice that there's not a huge difference between daily and continuously. Now, this was only over 3 years, and it was only $1,000. If we imagine a much larger account balance, we would see that this is a bigger leap, especially if we did it over a longer period of time. Okay, on the next page of notes, our very last page of notes, we are going to, just like we did with our uninhibited growth, we're going to solve for the other parts of this formula and work with our other solving techniques. So again, dog ear this page if you're having any trouble with these calculator parts.